Okay, the next part is, it says divide. Okay, so I'm going to do the same thing here. It says divide by a whole. So I'm going to write a whole there, and if you want to write a, I guess you can. So divide by a whole. And then it says if the fraction is not in simplest form. Okay, so the reality here is, and I'm going to draw an arrow down to where we are now, because now we're on the next set of questions. The reality on this one is, this is the one that we are going to spend a ton of time on. And I say a ton of time. We'll be doing this through the month of February. I can tell you that. And that is because this is a form of finding equivalent fractions that will stay with you for a very long time. In fact, you heard me say this before, but this could be something that could last all the way through college level math. And so this is very, very, very important that you understand what this next process is and this next skill is. Today, for today's notes, it's going to go pretty quick, but I'm going to start probably tomorrow or even maybe on Friday when you guys are in class with the substitute. We're going to, basically spend days where we're just doing nothing but this. And so underneath in your notes here, put another star. And underneath where it says divide, put this word. And this is a word that, again, you will hear quite a bit in class. And that word is simplify. So when you divide to find an equivalent fraction, technically you are simplifying. And so simplifying means to divide. Divide means to simplify. So you're going to hear me say, okay, can it be simplified? Man, you're going to hear me say that a lot over the next couple of months. And so let's kind of go down to where it's problems 4, 5, and 6, and let's talk about simplifying. Okay, let's look at question number 4. So here's the difference between multiplying and simplifying. When you simplify, you have to be very specific, meaning you have to pick a number that goes into both the numerator and denominator. When you multiply, your options are endless. You can pick any number you want as long as the numerator and denominator are the same, unless it's 1 over 1, which we never do that. So I can pick 65 over 65. I can pick 18 over 18. I can pick 7 over 7. When you simplify, your options aren't limitless. Sometimes your options might only be a couple of things that work. Sometimes your options, it's only one thing that works. For example, look at number 4. The fraction is 4/6. Okay, if I'm going to divide by a whole, I have to pick a number that goes into both 4 and 6. And so I have to be really smart about which number I pick. I'm not going to pick 1 over 1. That's not going to make sense. It's just going to give me 4/6 again. But I have to pick a number that goes into both. And so here's where those facts really come into play. So what I could do here is I could look at 4/6 and go, all right, well, I know something about 4 and 6. 4 and 6 are both even, so I'm going to use some divisibility rules, and I'm going to tell myself, well, I think 2 can go into both. So I'm going to write 2 over 2, and I'm going to think about, all right, well, if 2 over 2 can go in, then I'm going to now divide. I'm not going to multiply. I'm going to divide. So 4 divided by 2 is 2. 6 divided by 2 is 3. And now I have a final answer for 4/6. An equivalent fraction for 4/6 could also be 2/3. All right. So our middle problem, or our next problem, is 6/30. 6/30 can definitely be simplified. I could definitely pick a number that can go into both 6 and 30. But I want to look at this one a little bit differently. I want to approach this one kind of like what we were discussing before Thanksgiving break, and that was greatest common factor. So I had some students asking why we did greatest common factor, or why we did factoring for that matter. And so I said, well, just wait, it'll come back into play, and this is where it comes back into play. So I'm going to approach this one a little bit differently. I'm going to write this out to the side. You don't have to write this, but when you are simplifying, what you are trying to do ultimately is find the simplest form of a fraction, which means you are trying to get it down to its lowest numbers that it could possibly be for the numerator and denominator. So what I'm going to show here is a way or a strategy to simplify correctly, and it work every single time, and it could be something you kind of have in your back pocket if you ever get stumped or you get stuck. So what I'm going to do here is I'm going to take 6 and I'm going to take 30, and I'm going to factor 6 and 30 to go try and find the greatest common factor. So I'm going to start with the easy, 1 times 6 and then 2 times 3. That's pretty easy. 6 is a low number, so it's easy to factor. The next one for 30 is going to be 1 times 30, 2 times 15, because 30 is even, 2 can go into it. 3 times 10, that's a math fact. And then I'm going to write 5 times 6, that's another math fact. Now, I'm going to stop there because there's not any more factors for 30. And now I can look at both 6 and 30 and go, okay, well, what is my GCF, my greatest common factor? Well, when you are simplifying and you're looking for your greatest common factor, you can either show your work like I did here, and I'm going to circle it just to show, all right, that's a strategy you could do, or you could be really, really good at your math facts and you could just know it. And so if I look at 6 and 30 and go, okay, well, what is the biggest number that can go into both? I think my GCF here is going to be 6. And so now if I go back over and I simplify this by 6 over 6, I'm going to find an equivalent fraction, but I'm going to find an equivalent fraction that it is in the simplest form. In other words, I can't go any lower than that. So 6 divided by 6 is 1. 30 divided by 6 is 5. And I can go, okay, I've found an equivalent fraction for 6/30. 1/5 is an equivalent fraction for 6/30. Okay, the last one is 12/20. This one I'm going to go a little bit faster on. Remember, I can't just pick any number. I have to pick a number that goes into both. So what I'm going to do first is I'm going to give a wrong example. For example, a kid might go, well, what about 5 over 5? Well, 5 can go into 20. That's a math fact. 5 times 4 is 20. But 5 can't equally go into 12. And so 5 over 5 could not work here if I wanted to simplify. What could work, though, is a number that can go into both, and it could go into both equally. So I'm going to pick 4 over 4. Now, if I pick 4 over 4, 12 divided by 4 is going to be 3. 20 divided by 4 is going to be 5. And so now I have the fraction 3/5. 3/5 is equivalent to 12/20. Okay, so ultimately what we've done on this page so far is we've talked about 2 ways to find an equivalent fraction. The first way is using multiplication. Remember, when you are multiplying, this is very important. So if you learn anything today, learn this. If you are multiplying to find an equivalent fraction, any number will work as long as it's not 1 over 1. So like 2 over 2 will work, 4 over 4 will work, 6 over 6 will work because you're multiplying it by a whole. When you are dividing or you're simplifying, because that's the better term that we're going to be using more of, you have to be specific. You have to pick numbers that can go into both. So like on that last example, 4 could go into both 12 and 20. 5 could not. So you have to be really careful when you're finding equivalent fractions and you have to know specifically, okay, well, what am I trying to do here? Am I using multiplication? Am I using division? What's strategy am I using to find that equivalent fraction? Okay, I'm going to scroll up a little bit so we can finish off the notes here. And the notes are basically just some examples. The examples say, make your own equivalent fractions for each. Make one by multiplying by one whole and one by dividing by one whole if possible. So what I'd like to do on this page at the bottom is I'd like to look at basically the two types of math that we've talked about today, which is using multiplication to find an equivalent fraction or using division to find an equivalent fraction. All right, so let's look at number 7. Number 7 is the fraction 1/3. 1/3 is what's known as a unit fraction. Unit means 1, and so a lot of times you can think of a unit as like one of those little unit cubes when you used your base 10 blocks when you were younger. So a unit fraction, in fact, unit fractions are very important to us. We're going to talk about unit fractions quite a bit when we get back from our Christmas break. But number 7 is a unit fraction. What's unique about a unit fraction is a unit fraction is already simplified. So what that means is I can't pick a number to divide by 1 and 3. There's not a number out there that can go into both unless it's 1/1, but we never use 1/1. So that tells me as a mathematician, if I'm finding an equivalent fraction for 1/3, my only option here is to times it. Okay, so when I times it, I have the freedom to pick whatever number I want. So I'm going to pick 3/3. 3/3 is a whole because 3 in the numerator and 3 in the denominator are the same. And so I'm just going to multiply across. 3 times 1 is 3. 3 times 3 is 9. There, I'm done. 3/9 is equivalent to 1/3. All right, let's look at number 8. Number 8 is 8/20. Okay, let's think here. First of all, if my job is to find an equivalent fraction, I have the option to multiply, which I could here, or I have the option to simplify or divide. I think I'm going to use dividing on this one. I think I'm going to simplify. And the reason why is because if I'm looking at 8/20, I know there are some numbers that go into both 8 and 20. So even though I'm not there and you're watching this video, I want to see if you guys can figure it out. What if, just think about this, what if you factored 8 and you factored 20? Think about what would be the biggest number that would go into both. So I'll give you a couple seconds to think about that. What's the biggest number that would go into both of those? So I've got 8 and I've got 20. All right, you've had some time to think. I think you're on level if you thought of 4. So here's what's kind of interesting though. If you thought of 2, you're not wrong technically because 2 will go into both. But I think 4 is what I would want to use there. And that is because 4 is going to take this down to what's called the lowest terms or the simplest form for this fraction. So in other words, 8/20, if I divide it by 4/4, I'm going to get this fraction of 2/5. Well, 2/5 is as low as it can go, and it is an equivalent fraction. So I think it would be good for you guys to see that. Okay, last two. Number 9 is 5/8. Well, let's think about 5/8. Is there a number that can go into both 5 and 8 except 1/1? Well, if you're with me and you're paying attention today, the answer to that is no. There's not a number that can go into both. So that tells me if there's not a number that can go into both, my only option here is to multiply. Well, I can multiply it by anything. So I'm going to go with the easiest here, 2/2. 5 times 2 is 10. 8 times 2 is 16. We're done. 10/16 is equivalent to 25/100. Or excuse me, 10/16 is equivalent to 5/8. I was jumping ahead there. Okay, the last one. Ooh, number 10. I don't know if you guys see it, but right off the bat, money. I see money here. I'm thinking of quarters. Look at that, 25 100ths. That's how you would say that fraction. All right, for this one, I'm definitely going to divide. And I'm going to divide by quarters. Because I know a quarter would go into both of those. A quarter can go into a quarter. 25 divided by 25 is 1. 100 divided by 25 is kind of like saying how many 25s go into 100. Or how many quarters make a dollar, which is 4. So 25 hundredths is equivalent to 1/4. All right, so as you're finishing up these notes and you're thinking about today, specifically today, and really over the next several days, go back to the very beginning of these notes. Really think about what we started with. The word equivalent means the same or equal to. So we were looking for fractions that are the same fractions, they're equal, they have the same picture if you were to draw them out. We want to figure out equal fractions here when we're going over equivalent fractions. And there's two ways to do it. You can multiply, or you can divide, or what's going to be known as simplifying. So that part though, that simplifying part, that's the one we're going to be spending more time on. In fact, probably the rest of this week we'll be talking about simplifying. It's really, really, really important that we get simplifying down.